Electronics have a strange reputation when it comes to crop circles. People who visit these sites often report odd sensations, tingling in their bodies, sudden headaches, even a wave of nausea that seems to come out of nowhere. For years, these stories have been brushed aside as imagination or coincidence. But imagine this for a moment. What if the most advanced artificial intelligence ever built, trained on thousands of human languages, ancient symbols, complex mathematics, and encrypted systems, was suddenly confronted with something it couldn't fully understand? Not because it lacked data, but because what it was seeing didn't belong to any system it had ever learned. At first, everything about the AI was working exactly as expected. It was developed inside a high-tech research lab in Europe, where scientists had one clear goal: build a machine capable of not just recognizing patterns, but deeply understanding them. They fed it everything: ancient Mayan carvings, Tibetan mandalas, Gothic architectural blueprints, satellite imagery, astronomical data, abstract art, even encrypted communication systems. The AI processed it all effortlessly. Every image it analyzed was instantly categorized, every structure understood, every pattern placed neatly into a known framework. It didn't hesitate. It didn't struggle. It didn't make mistakes. The researchers were confident. This system wasn't just powerful, it was revolutionary. Then, almost as a joke, someone suggested something unexpected. Why not try crop circles? The room filled with quiet amusement. Crop circles had always been treated as curiosities at best, hoaxes at worst. Flattened fields with geometric shapes. Interesting, maybe artistic, but nothing scientifically significant. Still, out of curiosity, they fed the first image into the system. At first, nothing seemed unusual. The AI began analyzing the image, just like it always did. But this time it was slower. Not dramatically, but noticeably. A task that usually took milliseconds stretched into seconds. The team brushed it off. Maybe the image was complex. Maybe it needed more processing time. Then they added another image, and another. With each new crop circle, the delay increased. That's when something unexpected appeared on the screen. Algorithmic entropy spike. This wasn't a normal message. It was a warning. One that only appeared when the system encountered something far more complex than anticipated. Something outside its predictive models. In simple terms, the AI was signaling something isn't right. The mood in the lab shifted instantly. What had started as a light experiment was now something else entirely. As more crop circle images were processed, the situation grew stranger. The AI wasn't just slowing down anymore. It seemed stuck. Its purpose was simple: analyze structure, detect patterns, identify symmetry, and assign a category. Crop circles should have been easy. They had symmetry, repetition, balance, clear geometric organization. Everything the AI was designed to understand. And yet, it couldn't classify them. Not as human-made. Not as natural formations. Not even as abstract art. Every rule was being followed. Yet the conclusion didn't fit anywhere. Then came the most unsettling response of all: uncategorizable. No one in the lab had ever seen that word appear before. The AI was never supposed to give up. Even uncertain data would usually be forced into a closest match. But this time, there was nothing. No approximation. No guess. Just a clear, repeated conclusion. This does not belong to any known category. And the strangest part? The AI wasn't confused. If it had been confused, it would have produced errors, contradictions, or random classifications. Instead, its response was precise, consistent, almost deliberate. It was as if the system was saying, I understand what I'm seeing, but it doesn't belong to the world I was trained to understand. At that moment, the researchers realized something unsettling. This wasn't a glitch. This was a boundary. Determined to go deeper, the team isolated one particular crop circle, an image that had triggered the strongest reaction from the AI. They zoomed in. At first glance, it looked like a complex geometric design, but the more they studied it, the stranger it became. The structure wasn't just geometric. It was layered. Spiral patterns radiated outward from the center. Wave-like forms overlapped each other. The entire design resembled interference patterns, like the ripples formed when waves collide in water, or the way light behaves under certain conditions. The AI recognized this too, but then its behavior changed. It stopped treating the image like a picture and started treating it like a signal. It began analyzing the crop circle the same way it would analyze encrypted data, searching for repetition, structure, hidden sequences. It was trying to decode it. But when the researchers attempted the same thing manually, they found nothing. No binary structure, no recognizable encryption, no known coding system. And yet, the AI continued treating it as if it contained information. This raised a deeper question. If this isn't a code, then why does it behave like one? That's when Dr. Elena Krabsov, the lead data analyst, stepped in. Unlike others, she didn't dismiss anomalies. She approached them as puzzles. Her first test was simple, but powerful. Compression. In normal cases, when you compress an image, its file size decreases. Patterns with repetition become smaller because redundant data is removed. But when she ran the crop circle image through compression, the file size increased. At first, they assumed an error. They tried different algorithms, different systems, different methods. Every time, the result was the same. The more they tried to compress it, the larger it became, which meant only one thing. The pattern wasn't simple. It was deeply layered. So much so that the system had to generate additional data just to process it. Dr. Elena compared it to DNA, where massive amounts of information are packed into a tiny structure. But even DNA follows rules. This didn't. And yet, it still maintained perfect structure. That contradiction changed everything. The team began to shift their perspective. This wasn't just a strange image anymore. It might be something intentional, something designed. Then came the field investigation. When researchers arrived at the actual site, everything looked normal at first. An open field, gently moving crops, quiet and undisturbed. But the moment they stepped into the crop circle, the difference was undeniable. The plants weren't broken. They were bent perfectly. Each stem was angled at nearly 90 degrees, yet still alive. Not crushed, not damaged, just shaped. Even more unusual, the plants were interwoven, layered over each other in intricate patterns, like fabric. This wasn't random flattening. It was construction, but there were no footprints, no tire tracks, no evidence of tools. It was as if the pattern had appeared without being physically created. Then they examined the soil, and things got even stranger. They found microscopic crystalline structures. Tiny particles fused together as if exposed to intense heat. There were also metallic microspheres, perfectly round droplets that typically form when metal melts and rapidly cools. Magnetic tests revealed alignment patterns, as if an invisible force had organized particles in a specific direction. These are effects usually associated with high-energy electromagnetic exposure, but there was no known source nearby. No machinery, no power lines, nothing. At this point, the mystery had grown beyond a single event. So the team expanded their study. They gathered over 200 crop circle images from different countries, different years, and different environments. Then they fed them all into the AI. At first, the system performed normally. It identified Fibonacci spirals, recognized complex mathematical tiling, categorized known geometric structures. But when it reached the most complex crop circles, everything changed again. It created an internal distinction. Not man-made, not natural, but something else, a third category. Unofficial, undefined, unknown. Then came the breakthrough. The AI began linking patterns across different locations. At first, the similarities seemed coincidental, but they weren't. Identical structures appeared in different countries, years apart. Some designs were exact matches, just rotated. Others shared identical ratios and proportions. It was as if the same blueprint had been reused globally. When researchers mapped all the crop circles together, a realization emerged. This wasn't random. It was a system. Each crop circle was like a piece of a larger puzzle, a node in a distributed network, a fragment of something bigger. The team developed a theory, a distributed signal system, not a single message, but many parts forming a larger structure across the planet. Then they analyzed the timeline. Earlier crop circles were simple, basic shapes, circles, lines. But over time, they evolved. More complex, more precise, more advanced, like something was learning, improving, upgrading its designs. And then came one final discovery. When these patterns were shown to people during brain scans, certain areas of the brain became highly active, regions linked to deep pattern recognition and emotional processing. People didn't just see the patterns, they felt them. The AI gave this phenomenon a name: neurosymbolic messaging, a form of communication not based on words, but on shapes, structures, and perception, something that bypasses language and speaks directly to the mind. At this point, the question was no longer about crop circles. It was something much bigger. If this is a message, who or what is sending it? Is it the work of an advanced civilization, an unknown natural phenomenon, or something that has always been here, waiting to be understood? And if one day we finally decode it, if we truly understand what these patterns mean, then the real question becomes, what happens next?